Hello and welcome. Today we're going to look at motion, but specifically graphs. Today as we're looking at graphs of motion, we remember there were three categories that we looked at. Constant position, and this is when we're standing still or stationary. Okay. Constant speed and then constant acceleration. So these are the three things that we can look for, and we will be analyzing three different graphs. Now, when I say the word motion, it affects three things. I cannot move across the room if I do not change my position. I cannot move if I don't change my speed. If I'm standing still and I have to move, then I also have to accelerate and decelerate. So the word motion consists of three parts. Okay, so our position time or our displacement time graph, ST, our speed or velocity time graph, VT, and our acceleration time graph. So for each of these graphs, we will use these labels, and it will always be like that. So S stands for displacement or position, V stands for velocity and acceleration. So why is there then three graphs? What we will see now is when I'm standing still, if I specifically look at my position, I can draw a graph. But while standing still, I can look and see something about my velocity and about my acceleration. So all three graphs describe or focus on three aspects of the motion when I'm standing still. These three graphs focus on aspects of the motion when I'm traveling at constant speed, and these three graphs focus on different aspects of motion when I'm accelerating. So let's use a simulation to clarify what we are saying. In this simulation, the person is standing still. So he is at 0 meters. I'm going to move him to a different location. I'm going to say he's going to stand at 4 meters. Okay, so he's at a constant position at 4 meters. If we start the clock, we're going to see the following. His position time graph is a horizontal line on 4. His velocity, because he's not moving, is 0, and his acceleration, because he's not moving, is 0. If I had to change his position to 8, okay, and for that period of time that he was changing his position, we see a difference, but let's just clear, reset all, no. What we see now at 8 is standing still at 8, so there's 0, just at 8, horizontal line, his velocity is 0, his acceleration is 0. So when someone is standing in a constant position, whether it's at 0, at 4, at 8, we have a horizontal line, okay? And then because he's standing still, he has 0 velocity and 0 acceleration. So that is the first type of graph. When we're standing still, or when we're stationary, if we look at our displacement, we are not moving, so there's no displacement or no change in position. If we look at our velocity, there's no movement, so the velocity is 0. If we look at the acceleration is 0. In the next scenario, I'm giving the man a constant velocity of 5 meters every second. So as we play, we will see that he moves at a constant speed. His velocity time graph is a horizontal line. He is not accelerating, therefore he has 0 acceleration. But his position from where he started is gradually increasing, and therefore we see a diagonal line. Let's look again. If we look at the motion compared to the graphs, I want you to notice that the graphs all work at the same time. While he's changing his position, he's also changing his speed, and in this whole process his acceleration stays 0. So now what we've seen is when we've got constant speed, our speed is a horizontal line. Okay, our velocity of acceleration is still 0, and now we have a diagonal displacement. On the next graph, I gave him a constant acceleration, and you'll see now what happens. His acceleration is constant, so that means he's going faster and faster and faster. His velocity is increasing at a constant rate, but he is covering more distance every second because he's accelerating. So we can see that his position time graph is a curve. So with constant acceleration, we have a diagonal line at the acceleration. We have a horizontal line at the acceleration, a diagonal line at the velocity, and a curve. Okay, and how I always teach students to remember it is whatever is constant is diagonal. The acceleration constant is horizontal. So when the acceleration is constant, this graph is constant. When the velocity or speed is constant, this graph is constant. When the position is constant, the displacement time graph is constant. Anything that's after a horizontal line or constant line is 0. Anything right before a horizontal line is a curve, and a diagonal line, and anything before a diagonal line is a curve. So when I write it out, I quickly make these things and I look forward. Now, what's going to happen if I decelerate? Now, if we've got constant deceleration, we've got a ST, VT, AT graph, and deceleration is when I am slowing down, so I have a constant negative line. Okay? And when I'm decelerating, my velocity is decreasing. So when I'm decelerating, because I'm traveling fast in the beginning, I'm covering a lot of distance, and when I'm going slower at the end, I'm traveling less distance. It curves the other way. So these are the basic graphs that you need to know. You will have to memorize all of these graphs for physics for your IG and your AS years. If you're in AS, you're going to use this in mechanics and in physics. So if you've memorized it, it will always make your life easier once you have it in your head. Now we will be looking at the advanced graphs. When looking at the advanced graphs, what we are speaking about is what happens when I'm going faster, increasing my acceleration. So I'm accelerating more. Okay? So what we have then is we have an increase in acceleration. Behind the increase in acceleration, we can see it's a similar pattern. We have a curve, and that curve goes upwards. So when I'm increasing my acceleration, my speed is increasing the longer I accelerate. If you're doing IGCSE, you will not be looking at this graph. If you're doing AS mechanics, then we will look at this graph theoretically a bit later. But we can see that this is a straight line. This is half a parabola, which is a squared graph, and this graph would be a cubic graph. Okay, and the shape would almost look like that. Okay, so don't worry about this if you're on IGCSE. We won't be looking at these graphs. Okay, decreasing acceleration is a very important one because we use that when we're traveling at terminal velocity. That is when you start falling and you go slower and slower, and your acceleration goes less and less and less until you fall at constant speed. So in this case, it's similar to that shape, and before that is a curve that looks this way. Okay, and this is what we call the velocity time graph of decreasing acceleration. Okay. Now we will be looking at how does this apply and how do we use what we've just learned. You will receive a question. The first thing that you need to do with a graph, the first thing that you need to do is you have to identify which type of graph this is. This is a velocity time graph. So if I look at those graphs that I've memorized, we know that we're going to be looking at the middle graph. Now, if you go down your list of graphs, you look for the one that looks diagonally upwards, and you will see that it's this one, and it's constant acceleration. And then you look for the horizontal one, and you'll notice it's that one, which is constant velocity. And then you'll look for the downwards one, and the downwards one you'll notice is that one which is constant deceleration. So what you'll see is that there are three sections to this graph. So it's accelerating, moving at a constant speed, decelerating, and coming to a stop again. And this is how we break down the graphs in a question, and we answer questions for each section. So there are three significant sections to this graph.